Hey everyone, welcome back. And we will try to keep today's video very short, but on very important topic called as factor. You will be using factors very frequently, and in R, in fact, I have seen these factors are used so frequently compared to the other objects as you go in doing this analysis. So let's start with our journey to the understanding factors. Now, let's say you have decided to have a party on this weekend, and you requested your friends to respond with either yes or no, and this is the response that you got. Now, typically, what we do is like we will try to store this responses. So maybe I will use a new vector called as a response, and then I stored all these responses that my friends has given to me. Now you will see that okay, here we know that there are 49 people who has responded, and with these different values like yes, no, yes, and few of them even said as maybe. Okay, so in this case, typically, the way you can do the analysis is that I create another a vector, let's say response yes, and then I subset all the yes into it, and then I count how many yes are there, and then similarly I do it for no and then for maybe, but that's a tedious task, and when you have a powerful tool like R, okay, and you don't want to do this type of things. So R comes with this function called as vector sorry factor that will help you to convert your characteristic vectors into a factor, and then we will see how this will help you. So let's convert our response into a factor. So I create another variable as a type factor. Okay, so to do that you have to use the function factor, and now I pass my uh, the earlier vector that I created. Here I go. Now you see here another variable has been created, f underscore res, and now its type is a factor, and but now it has some additional information like it says w3 levels, then maybe no, and we know the next value would be yes, and then there are some numbers. Okay, so this is the basic difference between vectors and then the factors. So let's see what the response storing the values. So if I just hit enter, you see response has 49 values. Okay, and they are yes, no, yes, and maybe. But let's see what our factor has to show when we try to print it. Okay, and it says yes, no, and maybe. So you will see that if you see the sequence, it is the same. Okay, but when we try to print these factors, okay, there is a additional line that has been shown at the down, okay, which is showing this levels. Okay, maybe, no, and yes, and then there is another difference you can see here immediately is that uh, you know our character type vector, okay, values are stored in a double quote. Okay, you can see here all values has this double quote, but when I converted this the uh, uh, variable into a factor, okay, this double quote has gone. This is because internally factor stores as a numbers. So here you can see the values are actually stored in this format. Okay, and then it is marked with this level. So now you know that okay, maybe is 1, no is 2, and the third one is this yes as a value 3, and then you can see here the first value is 3, yes, 3 yes and 2 no. So that is how internally the values are stored. We will see this. Okay. So if you remember in earlier class videos, we have seen there is a function called class. If I try to see what is the class of my uh, variable f underscore res, and it is a type factor. Now, to see internally how the values are stored, we have to use the function called as type of. We have seen this earlier. So I say f underscore s. And now see here, the values are stored as an integer and not as a character. Okay, so that's the important thing that you should remember in case of factors. Okay, now storing these values, okay, internally as in integer, has a lot of advantages. Like, you can do immediate aggregation, or you can do this summarization very easily. Now the quickest way to see how many people had said yes, how many people had said no. Okay, to do that, I will now use this function table, okay, which will give me the values, okay, in a tabular format with these values. So now you say there are 6 people who said maybe, okay, 19 said no, and then 24 said yes. So quickly you have now able to summarize it, okay, or you can see how many has given yes or no. And you can quickly now let's plot it out. So I will use the function bar plot. Okay, we will see this in detail when we see the different functions. But for now, just see this bar plot. Will draw a bar plot for me, and then I will pass on these three values to it. So, and now here it's now graphically it has drawn a graph for me with this values. So now you can see maybe 6, no is nearly less than 20, something 19, and then yes has the more values. Now this is good, okay, that it has been quickly shown the graph. But you might be interested to see this no as a first column, and then maybe as the second, and then the yes as a third. Now this is typically how it happens, right? So to do that, okay, we will create the same factor again. Okay, so now see here, I'm using the same definition, but then I'm passing my labels myself. So now I will say the second parameters is the labels. So I will say I want the labels like, and then you have to pass on the another vector with these values. So I say I want the first value as no, then maybe, and then the last one is yes. Okay, and now let's try to print it out. See here. Now the first value is no, and then the second value is maybe, and then the last one is yes. Earlier it was maybe, no, and yes. Now it is no, maybe, and yes. How you want. Okay. So if I draw the graph again, okay, it will reflect my changes immediately. So this is how these levels are useful. But now how about that, you have to say that, okay, the no is has a lesser value, okay, then maybe is little greater value, and then yes. Okay, so to do that, we have another parameter that we can say, that is ordered. Okay, so see here, it says logical flag to determine if the label should be regarded as ordered. Okay, so we have given the order, and this will be treated as a ordered uh, values. So to do that, I have to just say true for this parameter order. Okay, and if I just try to print this value fres, okay, it will print out the same thing. Okay, and these labels are same, but now they have been marked, okay, to indicate which is the value that is greater and which is the value that is lesser. So that is how this function, sorry, this parameter order is useful. Now, before I close this video, now one more thing that I wanted to inform you is that it doesn't matter, okay, like how many levels you pass when you try to define it. So let's say in above case, okay, I have another parameter which says uh, no, maybe yes. Let's see, should be. Okay, so this is how four values I was expecting, let's say. And if I try to create it, okay, and if I just print this fres, okay, you see here there is another value should be is there, but there is no value. So that doesn't matter, okay. So you can create your levels with this additional parameters, but you cannot do it vice versa. So you can do it vice versa, but then you lose the values. So let's see, I create this again, but now I just remove this maybe, okay, and now I'm just using no and yes, passing no and yes, and I'm trying to create the factor. Now you know that we have some values with maybe, and let's see how this now behaves. See, R doesn't throw in any error. R doesn't given you any warning. Okay, but see, it has completely excluded the values which are there for maybe, and that has been replaced with NA. That's a missing value. So that is another important thing you should remember, that you know this is typically happens when you have a data which is maybe it's not properly formatted. Maybe some your yes is a capital yes, and some in smaller other values are in a smaller yes, and then you define a level which has the capital yes and no, and then what will happen. So see here, you have to be very careful when you define these levels. That is what exactly I'm just trying to explain you. So for example, no and yes, okay, so are in capital, so I am defining these levels as no, yes, okay, and then in if I try to create it, this factor, and see, everything is NA, because R is case sensitive. It tried to find out yes, everything in a capital, but you have all the yes in a lowercase. So that is a important thing that you should remember. Okay, thanks everyone. Bye.